Imagine just for a second looking up and seeing not just a star, but planets going around it,
Hmm.
and not just as little dots, but like a movie.
Yeah, watching alien worlds, actually orbiting their suns, it's pretty staggering.
It really is just awe-inspiring, isn't it?
Absolutely. It changes things from just like numbers and theories to something you can almost picture.
Exactly. And, well, that's what we're diving into today. You handed us these incredible sources, just packed with recent astronomy stuff that's totally pushing the limits of what we thought we could see.
hmm We've got these amazing direct images of exoplanet systems, some really strange things in famous space photos, and even some, let's say, unexpected ideas about how we might explore the universe.
Okay, so our mission here is to pull out the coolest bits from these sources you shared. We want to show you the breakthroughs, the really surprising details, and help you get why these observations are, so important, whether they're from giant telescopes or, well, other ways
All
mentioned.
right, let's get into it.
So first off, the big challenge for ages in astronomy has been actually seeing planets around other stars, right? They're just so tiny and faint compared to the star they orbit.
Uh-huh. Drowned out by the glare. Most of what we found, comes from indirect methods.
Like the transit method,
Yep,
where you see the star's light dip a tiny bit.
exactly. That tells us a planet's there, its size, its orbit, super powerful stuff. But you don't actually, see the planet.
Right, which brings us to direct imaging. This is kind of the ultimate goal, isn't it? Getting a picture, capturing the light from the planet itself.
Precisely. And that's what makes this first bit so exciting. One of the sources points out, well, a bit of surprise actually, that this wasn't like front page news everywhere. The very first direct imaging movie of multiple planets orbiting another star.
Wow. Okay, so this is the HR 8799 system we're talking about.
That's the one, about 129 light years away.
And the planets, they're not small Earth-like ones, right? These are big guys.
Oh yeah, massive. Gas giants, maybe up to 5 times the mass of Jupiter.
And that size is important for seeing them.
It's absolutely key. They're bright enough, relatively speaking, and they orbit pretty far out from the star. That separation makes it possible, just barely, to pick out their light from the star's glare. Trying this with a small, rocky planet. Forget it. Not with today's tech.
And what's really cool, as the source highlights, is this animation.
Yeah.
It isn't CGI. It's made from actual pictures taken over, what, 7 years?
Yeah, 7 years of observations from the W.M. Keck Observatory in Hawaii. They stitched those real images together.
Okay, so the movie covers 7 years, but their full orbits are way longer.
Way longer. The closest one takes maybe 40 years for one lap. The furthest one out is like a 400-year trip. So the movie is just a tiny snapshot of their dance.
Gotcha. And there's a theory mentioned that they might be locked in some kind of resonance, like their orbits are related mathematically.
Possibly a 1.2.4.8 ratio. It's an intriguing idea that astronomers are looking into. Their paths are described as, roughly Keplerian predictable, almost circular, but not quite perfect circles.
Makes sense they'd be far apart, being so massive.
Yeah, you'd expect that. And astronomers will definitely be watching this system long term.
Mm.
With planets this big, there's always a question about stability over millions, billions of years. Could one get kicked out eventually?
Huh. And one source mentions some surprising ways the system kind of mirrors our own. Something about harmonic motion, like Jupiter's moons.
That's right, potentially similar orbital dynamics, like with the Galilean moons, Io, Europa, Ganymede, and also the outermost planet orbits inside this huge dusty disk, a bit like our Kuiper belt, but apparently much more massive.
One of the most massive known within 300 light years, it said.
hmm And interestingly, the sources also note that there seems to be space closer into the star, inside the orbits of these giants, where smaller rocky planets could potentially exist.
So maybe undiscovered Earth-like worlds in there?
It's possible. Lots more to learn about that system. But it definitely feels like direct imaging, making these kinds of films of alien world is really starting to take off now.
Yeah. The sources also briefly mentioned a couple of other examples, right?
They did. Fomalhaut B, which was one of the very first planets imaged directly back in 2008, I think. And its motion has also been tracked over the years.
By a different team, yeah. And Beta Pictoris B.
Right. There's an animation of that one, too, from the Gemini South Telescope. Its orbit is seen almost perfectly edge-on from our viewpoint, which is pretty neat.
Seeing these actual motions, not just simulations, is, well, it's genuinely inspiring, as the sources put it.
Yeah.
Shows how far the tech has come.
Absolutely. But then, the material you shared takes a bit of a turn. It moves beyond just telescopes.
Yeah, this is where things get interesting, maybe a little weird. There's this image highlighted from NASA's Instagram feed, taken by Hubble. Beautiful shot of galaxies, stars, but right in the middle, smack dab in the center, is this really sharp uh, cross shape.
It really stands out. The source points out how anomalous it looks, nothing like the other galaxies or stars in the picture. Very distinct.
So the question comes up, could it be gravitational lensing? You know, where gravity bends light?
That's the natural first thought. But the source raises questions like, why would it affect only that one object so perfectly? And the symmetry is noted as being almost too perfect, a bright center, 4-point space just right around it. It doesn't quite look like typical lensing patterns we see.
So it's presented as kind of a mystery.
Yeah, a real cosmic puzzle without an easy answer right now.
Okay, then shifting gears a bit, but still visually amazing, there's this incredible picture of Jupiter from the Juno spacecraft.
Oh, yeah. Taken during a super close flyby, only about 15,000 miles above the clouds.
Wow. The picture is just sprawling. You see these huge swirling storms, some as big as Earth, apparently.
The detail is phenomenal.
Oh, wow.
And the colors.
Right, the oranges, whites, blues. The sources mention that's all down to different chemicals and particles and gases in the atmosphere. It's beautiful.
There's definitely a sense of awe in the description, and also a bit of wonder, like, how did Juno not just get sucked in at that distance?
Yeah, good point. But that stunning view of Jupiter then leads into a very different way of exploring it, according to the sources.
This is where the idea of remote viewing, or maybe astral projection, comes up. Presented as a way to sort of mentally travel to places, even across space, using meditation.
And the focus is on one person, Ingo Swann, described as a no-joke remote viewer, someone the CIA apparently hired decades ago.
That's the background presented. And Swann's claim, as laid out in the sources, is that he essentially left his body, flew to Jupiter, observed it closely, even went inside it and wrote down what he saw.
Okay, so he made observations.
He did. And the really crucial claim highlighted in the sources is that many of these observations, recorded years before probes got good data, were later supposedly validated one after the other by the actual probe findings.
Validated, like, how?
Well, the specific examples given are things like him describing a massive ring around Jupiter, kind of like Saturn's, before the probes detected it, and details about its chemical makeup, its atmosphere, some moons. The sources state there were over 15 specific points that later probe data matched perfectly with what Swann had described years earlier.
Matched perfectly. That's a strong claim.
It is. And the sources also share Swann's description of what he said he found deep inside Jupiter beneath the clouds. Huge rocky mountain ranges, some supposedly 50 miles high, and a surface like liquidy, sandy substance, almost like quicksand.
Mountains inside Jupiter. That definitely goes against the standard model of gas giants, doesn't it?
It certainly does. And the sources use this to argue that maybe gas giants do have solid cores or surfaces, challenging current scientific understanding.
Okay. And how do the sources frame this challenge to science?
Well, they present the view that science, often relies on theories that change over time. They argue that science has been dead wrong before, and that theories get adjusted constantly, maybe every 10 years is the phrase used. So the implication is maybe we shouldn't dismiss unconventional claims like Swann's at hand, especially if they seem to align with later data. It's presented as his claims versus evolving scientific theory.
Right. It's reporting on that perspective from the source. And didn't the sources also mention Swann claimed to have viewed the moon too?
Briefly, yes. That he claimed to have remote viewed the far side of the moon and saw things described as alien structures, towers, and cities. And the source connects this by saying it perfectly correlates to all of the research that everyone's been doing about the moon.
Correlates with other research.
Yeah.
And they suggest his book, Penetration, for more detail.
Correct.
So, wow, we've gone from seeing planets orbit distant stars with telescopes
To puzzling shapes in Hubble photos.
to amazing close-ups of Jupiter.
And then into these really extraordinary claims about remote viewing and apparent validation by later science, all presented in the material you gave us.
It really does show how technology is letting us see things in incredible new ways.
For sure. But it also leaves us with some big questions from the sources themselves. Like, what is that weird cross shape in the Hubble image? Is it just an odd lens effect or something else?
And, how do you even begin to process claims like Ingo Swann's, where observations, as the sources present it, seem to perfectly predict scientific discoveries years in advance?
It forces you to think about how we know what we know about the universe.
Yeah. This whole deep dive really shows you that our picture of the cosmos is always changing. It gets challenged by new data from telescopes, absolutely. But these sources also introduce, well, other kinds of information, other claims about how we might gain insight.
It's definitely a reminder that there's still so much out there we don't understand, and maybe even different ways to approach understanding it.
It's quite a journey through these sources.
It really is. From the technological triumph of imaging exoplanet orbits to the sheer beauty of Juno's view, and then these more challenging ideas about observation.
So we've seen alien worlds move, pondered cosmic question marks, felt the Jupiter flyby awe, and considered these really fascinating, maybe unsettling claims about remote viewing being validated.
It highlights the progress, but also the persistent mysteries.
And maybe it leaves you, the listener, with something to think about. As our tech lets us peer deeper and clearer into space than ever, could there also be other ways, maybe non-physical ways, that humans can connect with or perceive the universe?
What possibilities for understanding reality might we not even be considering within our current frameworks? It's definitely food for thought.